Perfect. First of all, I look at these three terms. I identify the fact that I can tell that it's a trinomial. It's in descending order. And since it's an equation, I will divide both sides by 3. 15x cubed divided by 3 is 5x cubed. 24x squared divided by 3 is positive 8x squared. And negative 63 divided by 3 is negative 21x. And 0 divided by 3 is 0. Dividing both sides of an equation by a number does not affect the solutions. Now, I see that the greatest common factor, so it's trinomially descending order, no negative leading coefficient, it's a, but it has a greatest common factor. I will factor out x. So, and now I'm down to the very last strategy in which the trinomial has a leading coefficient which is not 1, and a special product is not applicable here because the last term is negative and 5 and 21 are not perfect squares. So I will say, oh, I know. I'm looking for two numbers whose product is 5 times negative 21, which is negative 105. I prefer 5 times 21, or 5 times 3 times 7. This is what I prefer. And whose sum equals 8. Since the product is negative, I know that I'm looking for a positive and a negative. And I'm going to have to use all factors and come up with two numbers, one negative and one positive. And when I add them, one will be negative, as I've said. When I add them, I get positive 8. So from these factors, can anyone come up with two numbers? Use all three factors. Come up with two numbers whose product is the whole thing and whose sum is such and such. Very good. Indeed, 15 and negative 7. Do we all agree with 15 and negative 7? 15 and negative 7. Yes? Everyone? Excellent. Thank you. So then x, 5x squared plus 15x minus 7x minus 21 is set equal to 0. So this is the same as 8x. We only presented the same polynomial, but in 4 terms instead of 3. Why we do that? Because now we are ready to do what? We're ready to, excellent, thank you. We're ready to factor by grouping. Perfect. So these two and then these two. So x, what will you pull out from these two terms? Excellent. What is left in parentheses? Good. What should I have from the other two? Very good. Only now I look. Good. We check negative 7 times x, negative 7 times 3. So now x is outside, and so is the common factor, which is, and what is left in parentheses? Very good. Excellent. How many solutions do you expect? 3. Very good. And you will give me 3 solutions. Please give me 3 solutions. Very good example. Good pick. X equals, x equals, x equals. The first one is excellent, excellent. Very good. Excellent. Good. Is there anything else you worked on that you would like us to look at? Anything else? Do you have any questions on this problem? Any doubts here or questions? Any questions? Anyone? Anything else?
Can we try to factor the, like, no, trinomial?
Yeah, this was a trinomial.
This is a trinomial?
Yes. Do you have something else in mind? Do you have a particular problem in mind? 4 terms? Okay, very good. So let's look at not on this page. Let's look at the review for this chapter. You wanted it to be an equation or just factoring 4 terms?
Just
Factoring 4 terms. Okay, very good. Problem 10. Oh, actually 10 is, they already show it to us. That's fine. This is on page 434. So 6x squared plus 10x minus 3x minus 5. So actually this is also 4 terms. The problem from before. Okay, good. So we are given this polynomial, and notice that we could combine these two, but we don't want to. We're trying to factor by grouping. So what will you factor out?
X.
Careful. 2x. Very good. What is left in parentheses?
3x plus
What should I have from the other two, coming out from the other two?
3x plus
Excellent. And now?
-1.
Good. Excellent. So then what will you pull out? What is the common factor now?
3x plus
Very good. And in parentheses, very good. And you can always go back and check. Good. Do we need anything else from here?
I have a question.
Yes, please.
Can you walk me through on like the second or the first equal sign?
Yes.
You said like 2x. I'm sorry.
Yes.
How do you get that -1? I just forgot.
Neg-
There.
-1 times 3x is -3x. -1 times 5 is -5.
Cool. Thank
That's the only common factor of -3x and -5.
you. Okay. Cool. Thanks.
Good. Yes, please.
We pulled out 2x instead of just x because
I have to factor out the greatest common factor, not just a factor. It has to be the maximum possible that goes in both. Because otherwise I will not be able to match it. I will not. See, if I only factor out 2 here, this will not match that. Because I will have 3x squared plus 5x. And these two will not be the same. And if they're not the same, I cannot pull it out. I will not be able to continue and factor. Good. Anything else from this chapter? Okay, in that case, we'll start chapter 11, and I have to jump directly into 11.3, and we'll come back to the rest. Okay? On page 678. It's all of the same thing. A little bit more difficult situations. Still factoring, still solving equations by factoring. So 11.3, it's called solving equations by using quadratic methods. I don't like to call it quadratic method, but they have a point. I agree. I don't completely disagree with their assessment. Okay, I would like to start with problem 14. Yes, please.
Are you using the book?
Yes.
Can you tell me what page it's on? I don't have my book. It's online.
Yeah, I'm just going to write 14, and I didn't get the chance to, yeah. 14 on page 678. Okay, so we have x to the 4th plus 2x squared minus 3 equals 0. What is the degree of this polynomial?
4.
How many solutions do you expect? 4, correct. Is this a quadratic equation?
Wait, is it quadratic just
Exactly. Second degree. Is this a quadratic equation? No, because it has degree 4. A quadratic equation cannot have 4 solutions, right? A quadratic equation can have 2 solutions, but not 4. So this is not a quadratic equation. Now, here is a suggestion. It's not required, but I will use a substitution. I will substitute x squared, and I'll explain why I pick x squared. Let's say I'm going to say, I'm going to let y be x squared. So this is y. When I rewrite the equation, the second term will be plus 2y, the third term will stay, the equal symbol, and 0. But now the question is, what do I put as the first term? Because I can't put x. I can't have x and y in the same equation. Now, I'm looking at power 2, and I pick the smallest of the two to denote by y. So I could have said, okay, I'm going to denote x to the 4th by y, but that will not really work. So I chose the smallest power, and I said, let x squared be y, or let y be x squared. Then what should I replace this by? Do you all agree that this will be y squared? Because if you square both sides, the left-hand side will be x to the 4th, the right-hand side will be y squared. So if I denote x squared by y, obviously x to the 4th will be y squared. Would you all agree with that? So now I will have to call this equation, of course it's not quadratic, but it's quadratic in form. What does that mean? It can be replaced by a quadratic equation if I choose the correct substitution. It's not quadratic. It will have 4 solutions, not 2. But it can be replaced by a quadratic equation. Why will I ever do that? Because it's harder to solve this. And I know how to solve this. For y. I know how to factor. It's in descending order. It's a trinomial. No greatest common factor, no negative leading coefficient, no special product, but 1 is the leading coefficient, so I know how to factor it right away. How do I do that?
Take out y.
I thought we were ready for a quiz in factoring. That's what you said, right?
That's not what I said.
Oh, okay. Take it back then. Okay, so what is it? I'm taking it back. That's what I meant. So how do I factor y squared plus 2y minus 3?
Y,
Yes?
y,
So y outside times
y plus 3, y minus 1.
Very good. I already went through the strategy in my head. I cannot factor out anything from these 3 terms. Don't you ever say that let's factor out y, because y is not a factor, a common factor to all 3. So I can't do that. And I don't have 4 terms to factor by grouping. So then there are 2 options for y. What are the options?
y equals -3,
Excellent.
y equals 1.
Y equals 1. Perfect. So now I have 2 more equations on my hand, or in my hands. What equations?
The ones were in check, right? Or no?
Y equals -3 is actually what equation?
X squared.
Excellent. Equals -3. How do I solve this equation? Very good. Excellent. I apply square root. So then I have x. I should have the absolute value of x, but instead I have x, and I write what on the other side?
Square root of -3.
Careful. I need something very important. It has to have 2 solutions. It's quadratic. So what am I missing here? Exactly. Thank you very much. Plus or minus. So what is the square root of -3, please?
No.
Chapter 10, chapter 10, chapter 10.
Square root of 3
And
times square root of -1.
which is?
3i.
Very good. No, it's I the square root of 3.
Oh, no.
Very good. So what is the second equation? When I say y equals 1, what do I really mean? Excellent. What do I do now? Very good. I take the square root from both sides, and from here, what do I get? Very good. Very good. How many solutions did we expect? 4. How many solutions did we get? Good. Perfect. Next one. 17. Z to the 4th minus 13z squared plus 36 equals 0. Is this quadratic? No. How many solutions will it have? Excellent. But it's easier if I use a substitution. So I'm going to say let t, this time I like to use t, equals, what do you think? Excellent. So what will be the new equation that I have to solve? Can anyone dictate the new equation? Very good. Yes? Excellent. Now you will give me the factor form of this. Well, everything is on the floor. Do we have the factor form? We have the factor form of t squared minus 13t plus 36.
T minus 9, T minus 4.
Very good. Excellent. So then I have two solutions in t.
9 and 4.
Very good. So then what are the new two equations that I have to solve?
Z squared equals 9, Z squared equals 4.
Very good. So then how many solutions I get in z? Of course. That's
So you have Z equals plus or minus 3. And Z equals plus or minus 2.
excellent. Would you all agree with this? Yes? We agree? Well, if you agree with this, we have to move on to slightly more difficult situations. All of the same. Do we agree? Do we have a question on this problem? Acceptable, unacceptable? Can you say anything? Anything? Cool. Okay, it's cool. So let's look at 21. Same page. 5x plus 1 squared plus 2 times 5x plus 1 minus 3 equals 0. Any suggestions? Other than distributing and expanding 5x plus 1.
You treat the 5x plus 1 like x.
Thank you. So this is, I cannot use x, but I will use y. You're right. So let's say y equals 5x plus 1. Very good. And then the new equation is excellent. Excellent. Perfect. We just had this a few minutes ago. How do I factor it? Very good. So I have two options in y. And what are the options in y that we have to look at?
-3.
Excellent. And 1. So now y equals -3 really means what?
Negative 35x plus 1.
Yes, 5x plus 1 equals -3. Or 5x equals?
Negative 2.
Good.
Negative 4.
That's okay. So x equals? Excellent. Now the other equation means y equals 1 means what?
X plus 1 equals 1.
Very good.
Plus or minus.
Subtract 1 from both sides. We're not taking square roots. I can write plus or minus.
Oh.
I write plus or minus when I apply the square root here, and I write plus or minus. But there is no square root here. There is no need, I should say. Correct. So then 5x equals what? So that means that x equals? That's it. Very good. Any questions on this? Any questions?
Wait, what's this more difficult?
Because maybe it was a little bit difficult to see the substitution, maybe. Okay, here's the next one. 41. 2x to 2/3 plus 3x to 1/3 minus 2 equals 0. Any suggestions on this one?
No.
I'm ready when you are.
X to 1/3. X to 1/3. Make that y.
Excellent. Let y be x to 1/3.
2y squared plus 3y plus minus.
Equals 0.
Yeah.
Please, okay. Good. So then, let's factor this. 1 minute. And I'll put in my attendance. And that minute. Okay, Mike. Hi, Mike is not here. Why am I going to tell you once again? Chris. John. Can anyone get us started on this? Yes, please, Brian.
Factor.
Yes,
I got y minus 3.
but I have to show everyone what I'm doing.
Oh, so like multiply -2 and 2.
Good, and I get
-4
excellent. And the sum,
would be 3.
perfect. So therefore, the numbers you picked, 4 and -1.
Yeah, why negative 4?
Why not -4?
No, why negative 4?
Because the product has to be -4 and the sum has to be 3. These are the only numbers that work.
Why is this sum 3?
And the sum is always in the middle.
So you don't do anything with the middle part?
The sum is always the middle coefficient. And the product in this case is always the product of the leading coefficient and the free term. So then, what will be the new equation, please?
Y plus 4, sorry.
2y squared plus plus 4,
Minus 4y.
4y
Minus 1y.
minus y
Minus 2.
minus 2 Very good. So now from the first two terms, what will you pull out? Good. What is left in parentheses? Excellent. What do you have to have coming out of the other two? Excellent. Thank you. And now? What comes out? Very good. And in parentheses? Excellent. So then you have two solutions. We have two solutions in y, and they are? Perfect.
No. Yeah, 1/2.
Very good. You move one and divide by 2. Perfect. We are a very good team. So then, now I have two equations to solve. Instead of y equals -2, I have to write?
X 1/3.
Very good. X to 1/3 equals -2. Is there another way of writing x to 1/3?
The third root of x.
Excellent, thank you. How do I solve this equation now? Perfect, thank you. How do I solve it?
Third root of -2.
No? Very good. In order to remove the radical, I have to erase both sides to the third power. Good. What do I have on the left? On the left, I have x, and on the right-hand side, I have -8. And it comes with a question mark. Why does it come with a question mark? Yes, but remember that the hint that or the little reminder that I gave you, whenever you raise both sides to an odd power, the solutions will work, but you still have to make sure. So the cube root of 8 is indeed -2. So this is one solution. Now we have the other equation, y equals 1/2. What does that mean, really, for us here?
X to 1/3.
X to 1/3 equals 1/2. Is there another way of writing x to 1/3?
Root of x.
What do I have to do to both sides now in order to solve for x?
Raised to the third.
Raise it to the third power. And what do I get?
1/8.
1/2 times 1/2 times 1/2.
1/8.
1/8. Very good. So now I go back and check. Yes, it will work. So these are the two solutions of this equation. Do you feel that we need more examples like this one?
Yes.
Perfect. Let's look at let's look at 38. And 38 has x to 2/3 minus 2, x to 1/3, and -8 equals 0. Very similar. Let's look at this in 2 minutes. From the beginning till the end. I posted your next homework. It's due the following Thursday, Thursday the 10th. And it covers everything from this section. Everything from this chapter, actually.
Did you grade number 5?
I didn't. I had a very busy week and I apologize. I will return it to you on Thursday. I apologize for that. Tests are my first priority, but when it comes to homework, it happens sometimes, and I apologize, as I said, it happens that I fall behind. If you need any help, I'll come over and help you. Just let me know. If you finish this one, I would like to look at one more problem and then move on. Problem 18. Unless you think that we need to work on these problems more.
Excuse me.
Yes, please.
You have to select the lowest power, not 2/3, but x to 1/3. So that will be your y. So y is your x to 1/3. X. Okay. Now, if you square this, just to check that you get this, you square this side, you'll get y squared. And if you square this side, you copy the base and multiply the exponents. 1/3 times 2/1 will be your 3/3. So when you square both sides, you'll get y to 3/3. That's why you are allowed to write this, and this is correct. Okay. Better?
Okay, Eric had a question, and I'm sure that some of you have the same question, and I just want to make sure that this is clear. We have from power 2/3 and power 1/3, we have to choose power 1/3 to denote by whatever you want, except x, m, t, y, whatever you want. And if you square this side, you get y squared. And if you square this side, you copy the base and you multiply 1/3 by 2/1 to get 2/3. So that's why this is y squared. And that's the reason why we can replace this equation by y squared minus 2y minus 8 equals 0. Is this clear to everyone? Yes? Okay, perfect. Did you manage to factor y squared minus 2y minus, okay, how do I factor y squared? Now, please notice one thing. It is very easy to omit or forget, if you want, the equal symbol and 0. And if you do that, you will never solve, right? Because you are, by mistake, changing the equation into an expression. So notice that every time I write the factor form for, yes, Rebecca?
I have a question. Every time we rewrite it, do we have to put equal 0 as long as it's at the end? Because like every time I rewrite it, I'm not going to write equal 0, but does it matter as long as
I always write it because I will forget. I know I will forget.
Okay.
So actually, if you remember, if you see how I write the parentheses and then equal symbol just because if I forget, I mess up the whole thing.
Okay.
Okay, so then what do we have here?
Y minus 4,
Correct?
y plus 2,
Very good. So then we have two options in y.
y equals 4, and y equals -2.
Good. So then we have two options for the new equation. What does this mean?
X to 1/3 equals 4.
And what does this mean?
X to 1/3 equals -2.
Exactly. So now I have to solve those two and then come back and write the answer. So x to 1/3 equals 4 is the same with the cube root of x equals 4. If you want to write it, you don't have to write it like this. But I wanted to write it to remind you what it means. Or you can say from here, you can take it to the third power. You don't have to write this, the equivalent equation. So then x on the left and on the right hand side we have good. So go back and check. You have to check and it will work. And now the other equation is x to 1/3 equals -2. What do I do with that?
Turn it into a
Yes. So then raise it to the third power. Raise it to the third power and I have -8. And it comes with a question mark. You go back and yes, it checks. Did we all get 64 and -8? Okay, now we're ready to work on 18. Okay? So let's work on 18. I'm going to copy it here. Last one before we move on. Yes, please, Brian? Oh, okay. Please let me know if you need help. Can anyone give us the first step? So this is the method of substitution. We're substituting x squared, or y gets replaced by x squared. We're substituting x squared by y, or with y. Why is this possible? Because this equation is quadratic in form. For example, for this equation, you will not be able to use this method. This method is not applicable here. So even if you denote this by whatever you want, this will not be that squared. So for this equation, this method does not work. It works here because this equation is quadratic in form. This one is not quadratic in form. It cannot be replaced by a quadratic equation. Good. So if we let x squared be y, or y be x squared, what equation do we get?
9y squared plus 5y minus 4.
Do we all agree with this step?
Yeah.
Do we need more time? Or can we continue? Okay, perfect. So what will you do next?
Try to factor it
Good?
with 9 times -4.
Very good. So we want negative 36, and we want the sum to be 5. Only two numbers will give us a product of negative 36 and a sum of 5. Which numbers are those?
-4 and 9.
Very good. Very good. The product is this, the sum is this. No one can find two other numbers whose product is negative 36 and whose sum is 5. Excellent. What now?
Rewrite
Good, I'm ready.
9y squared plus 9y minus 4y minus 4 equals 0.
And when I do this, I'm not really kidding. I do the same thing. I write the factor from here without looking at the other two. I'm not kidding. Because who knows what I come up with by mistake? It's possible, right? So, what is the common factor here of these two? What do you have in parentheses?
Y plus 1.
What will be coming out from? Look, I write the parentheses, and then this. Because if I forget this, I will never get anything. So, what do I have here?
Y plus 1. Negative 4.
What next?
You find your answers, which would be negative 1 and 4/9.
What is next?
X squared equals 4/9, and x squared equals negative 1.
Good. What do I apply to both sides in both equations? Excellent. So what do I get in the first one? Remember, this polynomial has degree. How many solutions do I have to write?
4.
Good.
Plus or minus.
Excellent.
So the other one just. No, not the X squared. I mean, that'd be negative.
So formula. Plus or
Plus or
minus.
minus.
What is the square root of negative 1?
Is it I?
Oh, that's right.
Good. This completes 11.3.
How come in this problem we did like an extra step rather than the last problem?
Because the last problem didn't have anything in front of the first.
Oh, they have numbers like 9.
Yeah.
It had a leading coefficient of 1.
So when it has a coefficient of 1, you don't find the sum in the.
You don't have to, it's much easier.
Okay.
But if the leading coefficient is not 1, this is the method I recommend. It's easier for me to explain, and I think it's easier for students to understand, and the factoring by grouping is required in polynomials anyway.
Right.
So why put in more methods in there? So I stick with the factoring by grouping because polynomials use only factoring by grouping. Right. Good. I love when I hear that. Good. So let's move on to, or go back to 11.1. Or first of all, chapter 11. Chapter 11. Yes, please. Brianna?
Like, why do some answers not have like x equals like plus or minus?
Yes. So only when I take the square root. If a square root is not, if I don't apply the square root to get solutions, I will not write plus or minus. So, for example, if I have x squared equals 4, I will take the square root from both sides and I get x equals plus or minus 2. But if I solve x plus 2 times x minus 3 equals 0, from here I get x equals negative 2, and from here I get x equals 3.
So only if it's to the second power.
Yes.
No problem.
Yes. Very good question, actually. So I can't show it right now because we don't have all the tools. But it's an excellent question. What happens if I have this? It's in descending order. It's a binomial. No greatest common factor. No negative leading coefficient. Special product.
To be to the third root.
Please go back to the strategy for binomials. It's in your notes. X plus 2 cubed. Very good question. Means x plus 2 times x plus 2 times x plus 2. This is x squared plus 4x plus 4 times x plus 2, which is x to the third plus 4x squared plus 4x plus 2x squared plus 8x plus 8, which is x to the third plus 6x squared plus 10x plus 8. So it's a very good point you're making. I want you to see and never, ever say x plus 2 to the third power, because x plus 2 to the third power has 4 terms. Right? X plus 2 squared is this, which we know from 2 months ago. And then I just distributed x to these 3 terms, and I get this, and 2 to these 3 terms, and I get these 3 terms, and then I combine like terms. So you can never say that x cubed plus 8 is x plus 2 cubed, because x plus 2 cubed is this. So back to the strategy for binomials. How do I factor this? I'm ready when you are. Yes? No.
Wait, what are we factoring?
Malcolm, can I borrow the notes just for 1 second? Turn them to you in a blip.
X squared minus 2x plus 4.
So you said x plus 2 is correct or not?
Yes.
Okay.
Then x squared
Very good.
plus 2x.
It has to be minus. When I factor the sum of cubes, I have sum and minus. Plus, plus, minus. Perfect.
Minus 2x
Very good.
plus 4.
Excellent. So this is the sum of cubes, which factors into a binomial times a trinomial.
So what all the writing in blue? That's not the answer? Right.
No. So the question I had was, how do I factor x cubed plus 8?
Okay.
And the answer was x plus 2 cubed.
But you can't do that.
Of course not.
Okay.
And I wanted to show what x plus 2 cubed means. So we never ever say that again. X plus 2 cubed does not have 2 terms, but 4 terms. So I expanded x plus 2 so that it's embedded in our memory now that x plus 2 to the third has 4 terms. So x plus 2 to the third is not this. Okay? So this was just a side issue, just for us to remember that when we raise a binomial to the third power, we get 4 terms. Okay, so therefore, there are 2 options here. Can anyone give us one option? Excellent. X equals -2. What is the other option, which we cannot solve just yet? We will in 10 minutes. I'm going to get to this. The second option is x squared minus 2x plus 4. Exactly. But we cannot solve this. It's not factorable. So as I said, give me 10 minutes and we'll come back to this and solve it. Because we need one more piece of information that I will present right now. And then we'll come back and finish it up. Okay? So if we have this equation, that was Rebecca's question, right?
What?
That was your question. It was a very good question. You said, okay, what happens if it's something else, right? I don't remember exactly what. First of all, this was the question of plus. No, I think Brianna asked. So plus or minus 2, and then this was the option. And then I said, right, actually her question is very good. What happens if I have x cubed plus 8 to factor? And I get to this, 2 options, x equals negative. Of course, I have to have how many solutions? 3. So 1 will come from here, 2 will come from here, for a total of 3. But we cannot solve this. Give me 10 minutes. We'll come back and finish it up. I'll put it on the side or separate. Okay. So coming back to chapter 11. Very good question. Thank you. Chapter 11 deals only with quadratic functions. And of course, and equations. You just saw plenty of them that were not quadratic, but they were quadratic in form. Okay. In total, we have 4 different methods. 4 methods of solving quadratic equations. 1, 2, 3, 4. And the question is, can you please turn that off? Thanks. Put it away, please. So we have 4 methods, and the question is, why 4 methods? Why isn't just one enough? Well, the reason is, in certain situations, one is easier to apply than the other. And it is highly recommended